title of this lecture suggests, we're going to delve into the world of the humble Venn diagram to realize what a powerful tool it is. You probably used these somewhere along your education, whether it was in English class to analyze characters in a piece of literature, whether it was in history class to compare, say, two different cultures or two different city-states in ancient Greece. Probably what nobody told you is that they were developed by a English philosopher and logician. And first of all, you may not even know there was a job called logician. That's somebody who is a professor or a expert in logic. John Venn was a philosopher and logician in Cambridge, and he developed the use of these diagrams to help visualize the kind of categorical logic that Aristotle and others talked about in very abstract terms, and Venn developed the use of these diagrams as a way of understanding and visualizing complex ideas. So we're going to spend some time with them. Most of the ones we're going to deal with will either be two like this, and that's called a categorical statement. And if there's three, then we actually have a categorical argument. And so we're going to look at some of these. So I was able to locate a few comic strips and humorous ways to look at these. So here's this fellow. He's pondering whether or not he has a chance with that girl over there, and he decides maybe he should just chart it out. So he makes a Venn diagram. There's me. That's that girl over there, and never the two shall meet. And so he's decided to scratch her off his list. This, by the way, in categorical statements, this is actually an E statement. We're going to learn that. Anytime you say no S's are P, no chance that me and that girl will ever overlap. And so there you go. There is one look at a Venn diagram. I'm going to let you look at this one. You might need to pause the video for a moment so you can ponder this. This is done by a really cool artist, and he writes greeting cards, and he makes a couple Venn diagram references. So pause it, look at it until you see it. So here's another card by the same artist. It's called The World of Moose is his website where you can order his material. I'm going to let you ponder this one. This is kind of a sweet little sentiment. And if you happen to be a little more cynical about romantic things, I'll let you ponder this Venn diagram. So I ran across this diagram, and I think this really helps sort of illustrate how these categories work together. And there are scientists that use these to try to plot out the idea of an extra dimension or to a space-time continuum. These things can become three-dimensional, but let's imagine this. So there's the world of Wi-Fi, there's a world of power source, and there's a world of caffeine. And so if you have all three in the sweet spot, then you're in bliss. You've got caffeine, you've got Wi-Fi, and you've got power. If you have Wi-Fi and power, but no caffeine, then you're tired, right? Because you lack the caffeine. If you have power and caffeine and no Wi-Fi, you're annoyed, right? And you go to a place and you sit down and you're going to try to do a little work and they don't have Wi-Fi. On the other hand, if you have Wi-Fi and caffeine but no power, then you're frustrated because your laptop dies and you got no power source to plug into, so the Wi-Fi doesn't do you any good. And then of course outside those dimensions, right? There's the world that has none of these things. But this is sort of a way to understand. And what we're going to do is we're going to eventually talk about one of these as the subject, one of these is the predicate, one of these is the middle term. If we're going to try to form a categorical argument. But there you go. So there's your intro to basic Venn diagrams, and now we're going to talk about the 4 categorical statements. And they're listed by letters, A, E, I, and O. And also I have a link to a textbook that you can read this material as well. But here's a chance to sort of look at them in practice, and you might want to get yourself some Skittles. Get yourself some Skittles, and you may want to print or make a Venn diagram like this, and it will help you be successful as you go forward in this lecture.
Okay, so students, I'm going to discuss the use of Venn diagrams to understand categorical logic. Once we sort of master the basics of the Venn diagram, then we can go on to talk about categorical statements and then categorical arguments. But the most basic piece we have to master is the Venn diagram. And you probably used these since you were a small kid in school. And they were invented and brought by a guy named John Venn. He was a Cambridge mathematician, philosopher, and he was trying to use these to illustrate some of the concepts of logic that Aristotle developed, but they were very much sort of amorphous and they were hard to get your head around. So he used these diagrams to help illustrate very complex ideas of relationships, and these get more and more complicated. You probably used them in English class, maybe to compare and contrast two different characters in a novel, or maybe looking at the economies of, who knows, England and Madagascar, and you would put how are they different and how are they the same, and you'd use these Venn diagrams. You probably were never told that they were invented by a logician, used to discuss complex logical concepts. And to help us understand them, I'm bringing in a pack of Skittles. So you may want to pause this video, print out this sheet, which was in the email that accompanied the link to this lecture. And if you have them, you might want to get a pack of Skittles. I don't have any stock in the Skittle company, but it may help you sort of use them, manipulate them on the diagram. You could use M&Ms, you could use marbles, you could use anything you want, really. But I just want to sort of roll this out. So basically, a Venn diagram is designed to divide the world into two categories, and then to suggest that there is a relationship between the two categories. And we start off by labeling S and P, subject and predicate, and that becomes important later as we start talking about categorical arguments, that we need to be able to make sure we keep our predicates and subjects straight. But that's what we're going to do. So you get yourself a Venn diagram. You could print that out if you want to, or just draw it on a piece of paper. And if you want to get something to illustrate, manipulate, we can use this. You can get some Skittles or some other sort of candy or small thing you can manipulate on the screen. All right, so we need to open up our Skittles here, and we'll just open up our Skittles, and we're going to pour a bunch of them out here. My bag is pretty large here, so I'm not going to pour all the Skittles out, but there's enough to get the job done. Actually, that might be too many. Let me take some out of there. Okay, so the categorical statements, and there are 4 of them, and they're given alphabetical letters, so A, E, I, and O. And each follows this pattern. All S's are P, no S's are P, some S's are P, and some S's are not P. And so let's just sort of remember now, we're going to discuss this in terms of categories. So I'm going to use the categories of S is Skittles and P is pleasant. Okay? All Skittles are pleasant. That's going to be our A statement. This is the first categorical statement. All S's are P. So all Skittles are pleasant. So here, this P, this circle, represents all the possible pleasant things. Okay, and we're going to pretend for now anyway that everybody likes Skittles and they find them pleasant. So are there things that are pleasant that are not Skittles? Let me find my little pointer here. I'll use a little bone. Okay, so are there things that are pleasant that are not Skittles? Well, sure. Butterflies I find pleasant, or perhaps a Reuben sandwich is pleasant. A walk on the beach is pleasant. So there's lots of pleasant things, And then there are Skittles. This whole circle represents our Skittles. So we're gonna put the Skittles over here in the Skittle circle. Those are Skittles there. And over here are pleasant things. Now, our categorical statement says all Skittles are pleasant. So that means all the Skittles occupy the space in which both of these are true. Okay? Are there pleasant things that are not Skittles? Yes. But all Skittles are pleasant, so they are in this middle zone. All the Skittles are in the pleasant overlap. Pleasant Skittles. All Skittles are pleasant. Now, this section over here is void, is empty. And we were doing this in class, and you had a drawing. If I gave you a Venn diagram to draw, you would color this completely shaded because there's nothing here. You see, there are no Skittles that are not pleasant. All the Skittles are pleasant. So this is how you illustrate all S's are P. So there's an overlap. There are Skittles and there are pleasant. And all Skittles are in the category of pleasant things. Yes, there are pleasant things over here that are not Skittles, but we are only discussing the relationship between S and P. What is the relationship between Skittles and pleasant? All Skittles are pleasant. So that's how you illustrate an A argument. All S's are P. This is shaded. There's nothing here. All the S's overlap the P category, but there are things in the P category that are not in the S category, but this is all we know. This is what we're talking about. This is all we can say for certain. So this brings us to the E statement. The E statement is no S's are P. Remember that a categorical statement is saying that there are two categories, and I'm discussing the relationship between the two. In this case, we're going to say no Skittles are poisonous. So there is the world of Skittles, and there's the world of poisonous things. Are there poisonous things in the world? Sure, lots of them. Poisonous snakes and spiders and formaldehyde. I don't know what. Okay, so there's poisonous stuff over here. Are there Skittles in the world? Yes. But there are none that overlap. There is no relation. The relationship between the two is negative. So if I got out some of my trusty Skittles here and I pour them out, then I'm going to put all the Skittles over here. See, all the Skittles are over here in the S circle, but there's no relationship between the P and the S. There's no overlap. And so I would color this in. If I had a marker, I would just color that in and to illustrate that there's nothing here. So there are S's and there are P's, but never the twain shall meet. And so maybe I should just get a marker out here. Why not? So that's telling you that there's nothing in there. It's empty. It's void. There's no relationship between S and P. Well, there is a relationship, but it is negative. There are S's, there are P's, there are none that are both. So this is what's called the E argument. No S's are P. Now, let's discuss the I argument. Okay, A, all S's are P. E, no S's are P. In the I argument, some S's are P, and we're going to use the word purple. It's all Skittles and purple. So here we have the world of Skittles, and here we have the world of purple things. Are there purple things that are not Skittles? Sure. Barney the dinosaur, grapes, I don't know, all manner of things are purple. And there are Skittles. But, as we know, we'll unpack some of our Skittles again. Oh, I should put it up this way so you can see. Okay, we've got some Skittles here. And, sure enough, some of the Skittles are purple. Now, not all of them, not many of them, but some are. In fact, the rule in categorical logic is even if there's one, then there are some. Okay, so if I had only one purple Skittle, there are still some Skittles that are purple. So we see here there's a relationship. Remember, categorical arguments, categorical statements. There's categories and there's a relationship between them. There's lots of different kinds of Skittles. There's lots of different kinds of purple things, but some Skittles are purple. Now, we don't know that what other colors there are. Okay, the categorical statement is only making a statement of the existence of some Skittles that are purple. It might be that there's no other possibilities, but it still is true that some Skittles are purple. Okay, so if I told you that some students are present for class, it's very possible that that's all the students there are, that some could represent all. Okay, but if I say some, I mean that there's at least one that fills that category. Okay, there are lots of Skittles. Some of them are purple. Now, when we draw this out, if you were going to draw this and you were going to try to say some S's are P, Skittles are not, some S's are P, you would put an X here. And that X represents any number. There's at least one X. There's at least one S that is also a P. Now notice how that's different than all S's are P. In all S's are P, we put all the Skittles in here, purple and otherwise, because all S's are P. But in this situation, we are not talking about all the S's. We're talking about only the ones that are purple. And some, oh, hey, Mr. Green, what's he thinking there? So, some are purple, but there might be some that are not. You don't know that for sure. What you know for sure is that some are purple. And last but not least, we need to talk about the O statement. O statement, some S's are not P. Remember, we are categorical statements. Divide the world into categories and then make a statement about the relationship between the two, S and P. In our case, we're going to say some Skittles are not purple. So, once again, we get out our trusty Skittle bag. We pour out some Skittles. And sure enough, we can see that some Skittles are not purple. So we're going to take all the not purple Skittles and we're going to put them over there. Okay. Well, there's a lot of purple in this group here. All right, so here we go. So the statement is that some Skittles are not purple. Okay, see all these? They're not purple. Now, there are some that are purple, but that doesn't make any difference. That's not what our statement is. Our statement is some Skittles are not purple. And that is a true statement, and that's how you illustrate it. Now, it might be that we got a weird freak bag that had no purples in it at all. But this statement is still true. Some Skittles are not purple. Now, in this case, there aren't any purple that exist, but that's not what the statement is. The statement is some Skittles are not purple, and this is how you illustrate it. Now, we understand that there probably are Skittles in here that are purple, but logically, that they are not necessary. Okay, so if I told you in an example that some students are not present, some students are not present for class, I could be standing in an empty room. You know, it could be that who knows why, every single student decided to skip class on the same day. The statement that some students are not present is true. Now, it's also true that no students are present, but that's not logically necessary by this statement. All this is saying is there is a relationship between S and P, and that relationship is some S's are not P. They're outside of the P category. And so those are the four statements.
And of course, in order to be a true Venn Master, you must contemplate the nature of the universe. So here's one parting Venn for you to focus on as you head out to the rest of your day.